Parents often watch a child navigate a touchscreen with ease and assume they are prepared for a digital future. But scrolling feeds and playing mobile games requires zero understanding of how the software actually works. This is passive consumption. The user is consuming algorithms, not building them, leaving the child without any practical engineering or programming skills. Within the next 5 years, the global labor market will look radically different. Industries are rapidly integrating automation at a scale that eliminates the need for manual, repetitive task execution. Advanced robotics and artificial intelligence are already stepping in to assemble complex components, write standard code, and manage logistics. Roles that were considered highly secure a decade ago are being outsourced to machines that do not need to sleep. Yet the standard educational baseline hasn't reacted. Classrooms are still optimized for standardized testing, rewarding students for memorizing textbooks and repeating facts onto an exam paper. This diagram illustrates the flaw in that educational model. When we test a student's ability to store and recall information, we are forcing a small, fixed biological container to compete against an interconnected cloud network. A machine will always possess infinite, perfectly accurate recall. However, if we look closer at the human side, distinct biological advantages emerge. Machines struggle with ambiguous problem-solving, lateral logic, and physical creativity. These are the active traits that traditional memorization fails to cultivate. To thrive in an automated economy, a student must stop being a passive consumer of technology and transition into an active creator of it. This is the exact intervention point for Vidyodayam Robotics and AI Tools Training Center. Instead of reading about physics and engineering from a textbook, students build the mechanisms themselves. The curriculum removes theoretical lectures entirely, replacing them with physical construction. They start with the raw components. By physically wiring sensors, breadboards, and basic electronics, students learn exactly how hardware communicates with the physical environment. They bridge software and hardware using Arduino. Students push digital commands to the board, watching code translate into the physical rotation of a mechanical gear. If the code works, the robot moves. If flawed, it stays still. Students immediately see the result of their logic. This constant cycle of trial and error rewires how a child processes failure. A mistake is no longer a permanent academic penalty. It is simply a data point used to rapidly iterate and improve the design. Of course, dropping high-end robotics kits into a standard classroom does not guarantee success. The teaching environment must adapt to the material. Engineering requires intense focus and precise troubleshooting. This level of technical instruction is only effective in small, tightly managed batches, where mentors can observe individual progress. In an overcrowded classroom of 40 students, a teacher has no time to debug individual code, forcing students to rely on rote memorization just to keep pace with the syllabus. This map shows the historical concentration of technological resources in major urban hubs. Vidyodayam specifically builds its centers in rural communities. By deploying the exact same advanced curriculum outside of cities, the economic playing field begins to level out. Mentors guide these students to apply global engineering principles to local issues. They design agricultural sensors, automated irrigation prototypes, and weather monitors, solving the specific physical challenges they see outside their own windows. They learn syntax and circuitry, but more importantly, they gain direct access to the modern technology economy, regardless of their zip code. The most significant outcome of this training is invisible on a resume. The real shift happens entirely within the student's psychology. When a child commands a machine to move and it obeys, they develop creator confidence. They stop viewing technology as a magic box they are forced to buy and start recognizing it as a tool they have the power to build and manipulate. Because they explain their logic, troubleshoot errors out loud, and present their final projects, these students naturally develop sharp communication and leadership skills along the way. The child who simply scrolls a timeline is dependent on the application. The child who solders the motherboard and writes the code commands the application. For parents, the timeline is unyielding. Every month spent prioritizing outdated memorization techniques compounds the innovation deficit their child faces against a rapidly advancing automated workforce. The skills they will need to secure their trajectory must be built today. visit the Vidyodayam Institute and put the tools of creation directly into their hands.